is Justin Manuel G. Peralta from grade 12 St. Clement, and this is my performance task in physics. So we're gonna answer why pilots on an airship perform a loop. The pilots are oriented up-down at the top of the loop. And I will explain why the pilots do not fall out and why it's their natural tendency while in circular motion. Fall, a combination of lift from the wings and centrifugal force, keeping the aircraft and its occupants in a curved trajectory. Centrifugal force is the upward force experienced by the object in a circular motion and acts perpendicular to the direction motion. In a loop, as an aircraft turns upside down, the centrifugal force acts downward, counteracting the gravitational force. Centrifugal force is often described as the apparent upward force experienced by an object in a rotating frame of reference. When an object moves in a circular path, its inertia causes it wants to move in a straight line. In a rotating frame of reference, an upward force appeals to an object, pushing it away from the center of rotation. This apparent force is what we first law, or the planetary motion or the law of orbit. All planets orbit in the Sun is an elliptical orbit, the Sun being the center. This indicates the planet trajectory is different from perfect circle. Eccentricity planets do not revolve in complete circle, but rather in elliptical paths. With the Sun as one of the focus points, perihelions refer to the planet proximately to the Sun. Whatever aphelions refer to the planets distant from the Sun, Kepler's first rule allows astronomers to calculate the eccentricity and shape of the planetary orbits. And now the second law, or the law of planetary motion, or the law of equal areas. The radius vectors that is drawn from the Sun to the planets gives out equal areas in an equal interval. The radius vectors that is drawn from the Sun to the planet give out equal areas in equal intervals from time. The planet moves faster. The planet moves much faster closer to the Sun and slower farther away. Emphasize the fact that planets do not travel at the same speed throughout their orbits because the orbit is not circular. Planets' kinetic energy varies during its course. Its kinetic energy higher at the perihelion than near the aphelion. This suggests that the perihelion speed is greater than aphelion speed is lower. The third law, the law of planetary motion, the law of harmonies, and the law of period. The square of time periods of revolution of a planet is proportional to the cube of the semi-major axis of the ellipse traced out by the planet. The third law is vital in estimating the relative size of a distance of the planet in our solar system. It has also had the discovery of exoplanets orbiting stars beyond our solar system by measuring the fluctuation in the light with this exoplanet transit in the front of the host star. The two objects attract each other with a gravitational force of 16 units. If the distance between the two objects is double, what is the new force of attraction between the two objects? Newton formulated his law of universal gravitational based on observation and mathematical reasoning. He combines Kepler's law of planetary motion with his own insight and mathematical techniques, arriving at the conclusion that every particle in the universe attracts every other particle with a force proportional to the product of their masses and inversely proportional to the square of the distance between them. If the distance between two objects is doubled, the gravitational force between them becomes 1/4, and the original 1/4 of the original force. Therefore, if original force is 16 units, the new force would be 1/4 times 16 is equal to 4.
What is the reason why in a rotating ride in a park in physics?
Now boy, I'm gonna explain to you why the roller coaster in the park is faster and they didn't fall out. A rotating ride in a park involves principle of physics related to circular motion. When the ride is spin, riders experience centripetal acceleration directed towards the center of the circular path. This acceleration results from the combination of the rider's inertia and the inward force exerted by the ride. According to the Newton's law of motion, an object in motion tends to stay in motion unless acts upon an internal force. In the case of the rotating rides, the force is applied by the ride itself, causing the riders to continually change direction. The centripetal force required for the circular motion is provided by the ride structure, such as rotating platforms or arms. This force prevents the riders from moving in a straight line and keeps them within the circular path of the ride. The faster the ride spin or the larger the circular path, the greater the centripetal force experienced by the riders. Okay boy, this is the summary, and the physics behind a rotating ride involves a centripetal acceleration, centripetal force, and the Newton's law of motion to create a thrilling experience for the rider. Papasigaw yung mga sumasakay dito para mag-enjoy sila.